right, in your science book, section 5.5, it's titled Water's Energy. So this is the worksheet I sent home with you. It's called Energy, Work, Force. We've got a couple fun things going on here. At least I think they're fun. I like taking these notes. We get to draw silly pictures. So on the right side of your page is the vocabulary list of 4 words you should know as they relate to science when we talk about energy and work. And over here we're going to use our little things I provided for you. We got a stick guy, we got a piece of rope, and a large boulder to talk about these different terms. Step over here so you can pause the video and take the time to write down those words if you'd like. Energy in science is the ability to do work. Work, we're going to talk about that one first, really. Work is done when an object is moved. So if you are sitting there reading a book and you have the book on your lap, although your eyes might be moving and your brain might be thinking, if you are sitting there nice and still, you are not doing any work until you take your fingers and you move the page. Then you have done work. Hopefully it did not wear you out too much. If you are sitting still, when you are sitting still, not moving anything, work is not being done, even if your brain is moving and thinking. So work is done when a physical object is moved. So let's look at this boulder here, and let's make our stick guy move it, and he can move it in 2 different ways. We're going to keep this kind of simple because it really is just our definition of force. Force is the push or pull on an object. So let's put our guy on this side of the boulder at first, and he's feeling pretty strong, so he thinks he can draw him like this. He thinks he can just push the boulder and that he's going to be able to move it with just his muscles. So this forward motion is push as he tries to move the boulder forward. Probably it's too big for him and he won't be able to actually move it at all. So no work will be done. So he gets a rope and a buddy, and they tie the rope around the boulder, and he's going to push while his buddy pulls on the rope from this direction. That kind of looks like his arms. Here we go. Push, and of course, you probably already knew these words. Pull. Push and pull on an object. Now, here's the thing that's working against them, though. You've got other forces at work. This giant rock is constantly being pulled down towards the center of the earth by that thing that pulls everything down to the ground when it's up in the air, gravity. Gravity pulls everything down at the same rate, but the bigger and heavier an object is, the harder it's going to be to move. And the bottom of your paper has a little star right there that points out, in order for you to lift something, you must exert more force than gravity down on that object. So gravity is always pulling down. The size of the object is going to make a difference. If you are going to try to lift a 15-pound box, 15 pounds, but you are only strong enough to exert 14 pounds of pressure, 14 pounds of force, 14 pounds of force, can you move the box? No. You need at least 16 pounds of force to move that box, pushing or pulling. So when we think of lifting a box, that action would be included with the pull because you're not pushing it against your body but bringing it towards yourself. So make sure you get these lovely graphics down, and then you're going to actually turn your piece of paper over, and we're going to talk about the 2 kinds of energy, potential and moving. Hopefully you've just turned your paper over from the notes I gave you and you can write energy across the top. And these ones are pretty quick and to the point. Energy. All moving things have energy. Running water, a ball being thrown, fourth graders, anything that moves has energy. It's being used. Some not moving objects, though, have energy stored in them. It is ready to use. They have the potential to move, they just aren't moving yet. I like to think of it this way. Let's talk about the not moving objects first. This is like a person quietly, have fun drawing this, quietly and peacefully meditating, right? They're sitting there. Let's see if I can draw it. Got their legs crossed, their fingers like that. They have energy stored inside of them, but they're not moving yet. They're just staying in one place. But the energy is there, it's just not going anywhere yet. This is called potential energy. This person can move. They have energy stored up, ready to be used, but they aren't moving right now. Potential energy. It's also called stored energy. A great way to think about this is with a rubber band. A rubber band that you pull really tight has potential or stored energy. It's not moving yet, except the movement I'm doing, but as soon as I let go of it, it is going to be forced to use that energy and move somewhere, maybe backwards, maybe at the object you're shooting. A rubber band has great stored energy. So when that energy turns into moving energy, this one now is like the fourth grader that is just so excited for everything. They're jumping up and down and won't sit still. Yay! This is moving energy. Energy that is being used. Energy that is being used. Water's energy is amazing. Water's energy has been used through things like dams and water wheels. There's steam energy, and people have figured out ways to capture and take all of this energy that water has when it is moving to power, to make power plants and use electricity. So potential energy and moving energy are potential energy and moving energy. I don't know how to end this. These are your notes for now. Potential energy, moving energy. Two different kinds of energy. When it's stored, it's not being used, but it has the potential. When it's moving, it's being used. All right, bye-bye.
Mom.